Hi to everyone. In this session, we are going to discuss about the Avl trees. So, Avl trees are nothing but the name of the scientist where we got the name of the tree, that is Avl, that is Adelson, Welsky, and Landis tree. So, this tree is also known as self-balancing binary search tree. That is, Avl tree is also a binary search tree. That is, every Avl tree is a binary search tree, but not every binary search tree is not a Avl tree. So, that is the important point here. So this follow the properties of whatever that is followed by the binary search tree, but here we are going to be concerned about the height balancing of the tree. That is, if we calculate the balance factor, that is height of the left subtree minus height of the right subtree, it must be in the order of -1, 0 and +1. So that's why if it is less than -1 or greater than +1, something like -2 and +2 and so on. So if it is violating the property of Avl tree, that is every Avl tree must be a height balanced binary search tree. That is, it will self balance itself with the help of the rotations. If the property of the Avl tree violates, that is, we have to compute height balance factor at every point of time. That is, balance factor is found out by the formula height of the left subtree minus height of the right subtree. There it must be in the order of -1, 0 and +1. So at every moment, if the balance factor of each and every node must be between these three, that is -1, 0 and +1. So if it is not the case, then this is violating the property of Avl tree. Then we have to make necessary rotation depending upon the way in which the elements are inserted or deleted to make the tree from unbalanced state to balanced state. Let us check how it is having the properties of self-balancing. Suppose if we take this the current example where we are going to have the root node 41. So all the elements like in the binary search tree that are in the left subtree are having lesser value, that is 11, 20, 29 and 32, and all the elements which are present in the right subtree are having greater value when compared to the root node 41, that is 50, 65, 72, 91 and 99. All these elements in the right subtree are greater than the root node 41. So that's why it will follow the property of binary search tree. And one thing that is more important when we talk about the Avl tree is that is height balancing. That is a balancing factor, that is calculating the height of left subtree minus calculating the height of right subtree, which is equal to, must be in the order of -1, 0 and +1. So let us check the four kinds of operations, that is three operations, that is searching, inserting operation and deleting operation. So when you want to search for an element, we have to search whether the element is present in the Avl tree or not. So as it is in the binary search tree, same as, so it will just go through the location and just it will return the element is present, that is 29 we have searched for. So that's why, so let us check for the other type of operation, that is called as insertion operation. That is, we just take an empty tree and we start constructing, that is, we start constructing the number of elements one after the other. And how you are going to check here is, that is the first kind of insertion where we are going to apply the single left rotation. So now let us check. The elements will be inserted one after the other in a sequence like 8, 6, 10, 4, 7, 9, 11, 3 and 5. So in this way the elements will be inserted, and see what will happen here, in which way the Avl tree is going to be constructed. So the first element to be inserted here is 8. So after that the element that is going to be inserted here is, sequence is coming, the sequence is 6. It will lesser than the root node, so it will go to the left subtree. And next one is the element is in the sequence is 10. It will go to the right subtree and it will add as a right child. of root node 8, and next one it will go to the sequence, next element in the sequence, that is 4. So 4 is less than the root node and 4 is less than the parent node 6. It will add as the left child of parent node 6. And next comes in the sequence is 7. 7 will be lesser than the root node 8. So it will go to the left subtree and will add as right child to the parent node 7. And next one coming in the sequence is 9. So everywhere after each and every construction of the AVL tree and also in the insertion, we are going to compute the balance factors. So we have to compute the necessary balance factors for each and every node. Now 9 will be added as the left child of the parent node 9. And next one, we are going to calculate the balance factors at each and every insertion of for each node. And next one in the sequence is 11. 11 will be added as right child of inserted as right child of the parent node 10. And next one, the balance factor of the 10 is 0 and 8 is 0. So and next one is the, you have to compare the 3, that is lesser than the root node, it will go to the 6. And next one, when compared to the leaf node 4, it is also less, so that's why it will be added as left child of the node 4. And next one, compare to the balance factor of 4 is 1 and the parent node is 6 is 1 and the root node is 1, balance factor is 1. So the tree is now balanced, so no rotation has been done. And next one in the sequence is we have 5. 5 is less than the node, that is 6, and next one it is greater than the parent node 4. So that's why it will be added as inserted as the right child of 4. So we'll check the balance factor, that is of 6 is 1 and balance factor of 8 is 1. So the after insertion of entire elements, the tree is now balanced. So in this way we have constructed some number of elements into this AVL tree. And next one, the first kind of insertion where we are going to do the single left rotation, that is other name for single left rotation is left rotation. That is, if the any child node is added as a left child of the leaf node of the left subtree, then it is called left rotation, and also the other name is called as single left rotation. So now we are going to insert the node 2 here. See what happens. So it will check with the root node, that is 8. It will go to the left subtree, it will go to the 6, and it will move towards the left subtree again. It will go to the 4, and next it will go to the left child 3, and 2 is less than 3. It will add it as the left child of the parent node 3. Now the tree will be violating the balance factor, that is balance factor of 4 is 1, balance factor of 6 is 2. So at this moment the tree is going to be entirely rotated, that is single rotation is done, so that the balance factors will be in the order of +1, 0 and -1. So if it violates the property, that is in previously it is 6, there the balance factor became +2, so that's why if it is +2 it will be violating the property of AVL tree. Then we have to make necessary rotation, that is called single left rotation, where the elements are rotated one step in the left subtree towards other direction. So automatically if we compute the balance factors now, all the balance factors will be in the order of -1, 0 and +1. So next one, we see the second kind of insertion, that is called as element that is there inserted as a right child in the right subtree, that is called as right to right rotation. That is also a single rotation, that is called single right rotation, what we are going to see now. So for that we will see the create an empty binary tree and next empty AVL tree, and we are going to insert the elements one after other in a sequence. So first of you are going to have 7, next we are going to have 5, next one is 9, and next one is 4, 6, 8, 11, 10 and 13. So in this way we are going to add the elements. Now see in which way the elements are going to be, AVL tree is going to be constructed by following the necessary properties of both binary search tree and also the property of the AVL tree, that is the balance factor. So first 7 is inserted and 5 is inserted as the left child of 9, and next one is 9 we are going to insert, that is inserted as the right child of root node 7, and next we are going to insert 4. 4 is lesser than the root node 7 and also lesser than the parent node 5, so that's why it is going to be inserted as the left child of 5, and next one we are going to have 6 which is lesser than the root node 7, it will be added as the right child of 5, that is it will go to the left subtree. Now compare with 5, it is greater than 5, so we have to add towards the right child, and next one we are going to have 8. 8 is going to be the higher than the root node 7, so it will go to the right subtree and it will be compared with the 9, so 8 is lesser than 9, so that's why it will be added as left child of the node 9, and next one it comes in the sequence is 11. 11 is going to be inserted as in the right side. Why? Because it is greater than the root node 7, so it will be inserted as the right child of 9, and next one we are going to be insert in the sequence is 10, so 10 is greater than the root node 7, and next it will be inserted as the left child of the parent node 11, and after that at last we are going to insert 13. So now the 10 is inserted as the left child of 10, 11, and next one last thing that we are going to insert here is the that is 13. So 13 will be inserted as the right child of 11. So at each and every moment we have to calculate the balance factor, that is height of the left subtree minus height of the right subtree, or we have only one node, balance factor will be calculated height of left child minus height of left child, that is called the balance factor. And next one what we are going to insert is 12, that is adding the node as a right child in the right subtree, then it is called right to right rotation. So that's why it is called single right rotation is going to be performed after adding the element 12. So 12 will be compared with the root node 7 and 12 will be added as the left child of 13. So after this, observe carefully, the rotation is going to be performed. Why? Because the balance factor of 11 is minus 1 and the balance factor of 9 is minus 2, which is violating the property of Avl tree. At this moment, the tree is going to be rotated towards another direction, so that the balance factors is going to be satisfied the factors of minus 1 and 0 and plus 1 in this order. So the tree is said to be now balanced. So this is called second type of insertion, so that we are going to do the second type of rotation, that is called single right rotation or right to right rotation. Why? Because right child we have added in the right subtree, and next one is we are going to have the third kind of insertion, that is called left to right insertion, where we are going to add the element as a left child in the right subtree. So here we are going to create an empty tree and we are going to add sequentially like before. 8, 3, 10, 2, 5, 9, 11, 1, 4, 6. So in this way we are going to insert the elements and construct the Avl tree. 8, 3, 10, 2, 5, 9, 11, 1, 4, 6. So 8 will be the root node. As usually the first element will be the root node, and next element is 3. It is lesser than the root node 8. It will be inserted as the left child, and next one is 10. It will be inserted as the right child of the root node, Why? Because it is greater than the root node. Next one is 2, which is lesser than the root node 8 and also lesser than the parent node 3. It will be inserted as the left child of node 3. And next one we are going to have 5. 5 is inserted as the right child of 3. Why? Because it is lesser than the root node 8. It will go to the left subtree, where in the 3 it is greater than 3, parent node 3. So that's why it will be inserted as right child of 3. And next one we are going to have in the sequence is 9. So 9 will be inserted as the left child of the node 10. And next one we are going to have in the sequence is 11. 11 is going to be inserted as the right child of 10. We will compare with the root node 8. So it is greater than the root node 8 and it will go to the right subtree, that is 10, the parent node. And next one is 11. It is greater than the parent node 10. It will be inserted there. And next one what we are going to have is 1. So 1 is going to be inserted in the left subtree. The left subtree, it will go to the left subtree again 8 and it will go to the left subtree 3 and again it will go to the leaf node 2 and it is lesser than the node 2. So it will be added as the left child of 2. And next we are going to have is 4. So 4 is lesser than the root node 8. It will be added in the left subtree itself and it will be added as the left child of the node 5. Why? Because it is lesser than the value of 5. And next one, the element comes last in the sequence is 6. 6 is going to be lesser than the root node 8. So it will come to the left subtree and there in the left subtree it is going to be get added. So here it will go to the left subtree and the left subtree consists 3. It will go to the move to the right and there we are going to have 5 and as a right child of 5 it is going to be get added. And next one, after adding is completed, after construction of Avl tree is completed, we are going to compute the balance factors. So there is no violation of balance factor, so that's why we don't have any rotation here. So the tree is an Avl tree and it is a balanced now. Now we are going to insert one more element, which is 7. So after inserting 7, see what will happen. So 7 will go to the left subtree, that is lesser than the root node. It will be added as the right child of the left subtree. That's why it is called as left to right. So left subtree and it will be added as right child. So that's why left to right rotation. So the rotation is going to be performed now. See carefully, that is we are going to have the balance factors. So the balance factor of 8 is 2, which is violating the factor of these 3. That is, first we are going to move the tree towards the left and again we are going to rotate towards the right. So that's why this is called left to right rotation. So first we have made the tree towards the left and according to the binary search tree operation we have adjusted the elements, that is nodes in the right subtree and left subtree according to the satisfaction of the binary search tree, and also then we calculate the balance factors. Then it is balanced now. Why? Because it will be in the order of -1, 0 and +1. And last kind of insertion, it is called as right to left insertion, that is inserting in the right child, left child in the right subtree. So let us check the sequence of elements nodes what we are going to add. So we have 7, 5, 9, 4, 6, 8, 12, 11 and 13. So let us see the way in which the Avl tree is going to be constructed with the sequence of elements 7, 5, 9, 4, 6, 8, 12, 11 and 13. So as usual the root node is 7. Next it comes in the sequence is 5. It will be added as the left child, and next comes in the sequence is 9. It will be added as in the right child, and next comes in the sequence is 4. It will be lesser than the root node 7, and next one it will be lesser than the parent node 5. It will be added as the left child of 5, and next one in the sequence is 6. It will be added as the right child of the parent node 5, and next one it will comes in the sequence is 8. See where 8 is going to be added, that is in the right subtree. Why? Because it is greater than the root node 7. So 8 will be inserted in the right subtree, that is as a left child of the node 9, and next comes in the sequence is 12. So 12 is greater than the root node. The node it will be added in the right subtree as a right child of the parent node 9, and next comes in the sequence is 11. So 11 is greater than the root node 7, and it will be added as the left child of parent node 12, and next comes in the sequence is 13. So the 11 is going to be added. It will compare with the 9. Next we will go to the right side. Right child to compare with the 12, lesser than the 12. So that's why as a left side it will be added. And last node here in the case of insertion construction of the Avl tree is 13. So 13 will be greater than the root node 7. So it will be added in the right subtree, and in the right subtree it will be added as the right child of 12. So the entire tree is constructed with a given sequence of elements. In the balance factors are found to be in the order of -1, 0 and +1. So the tree is now said to be balanced. Now we will add an element which is 10, that will be added as the left child as the leaf node 11 in the right subtree. So that's why it is called right to left. That is in the right subtree as a left child of the leaf node we are inserting the element. So that's why this is called right to left rotation, right to left insertion. So first we are going to have the rotation that is towards the right, and then entire subtree, entire Avl tree is rotated towards the left. See here what will happen here is the balance factor of, that is first you are going to have the right, that is towards right, and entire tree is going to be rotated towards the left. So that's why it is called as right to left rotation. Now we compute the balance factors, the tree is now said to be balanced. So this is about the 4 types of insertion into Avl tree and 4 types of rotation, corresponding rotations, what we are going to do in case of Avl trees. So similarly in the deletion also, if any node is deleted and it is making the tree to be unbalanced, then you have to make balance by doing the necessary rotation, whether it is a single rotation or double rotation, and satisfy the properties of both binary search trees and also the Avl tree, that is the balance factor, and then you said to be the self-balanced binary search tree. Thank you.